I'm going to take off points, but because you will know what you got right or what you got wrong the first time. Hopefully you will continue to improve, grow stronger and stronger on these topics, but it is helpful when a test is coming to go and be like, wait, what did I miss? Especially on things like multiple choice problems, yeah? All right. Number 77, what is the limit of x as x approaches pi? It was meant to be easy. Did you all agree? Answer? Yes. I agree. Because you plug in pi and the answer is just pi, right? Good. Plug it in, pi. Number 78, the limit as x approaches 0, how I would summarize the question. You could have plugged in or you could have looked at the graph. As you approach 0, what was the best possible answer based on the answer choices they gave you? Non-existent, but struggle. Remember, these aren't actual AP questions. What do you think the actual answer should be? So if I were you, I would write down that infinity so that you remember, because that's what I'm going to want to see on a test or a quiz. Yes, it's non-existent, but it's not DNE. Not technically. We wouldn't stop there. We would answer with infinity. We would answer with infinity. I'm trying to think of another question, like in another discipline maybe, where this idea would exist. I don't know. All the examples are coming up short. I'll try to think of one for tomorrow. Number 79. What is the limit of f of x as x approaches 0? Okay, so then they were asking for x approaching 0. You guys getting what the terminology is saying, right? So much easier if we can shorten it using mathematical modeling or mathematical notation. What did you guys try to do? Plug it in, plug it in. What happens when you plug it in? No. 0 over 0? Uh-oh. So now what? Okay, how do you keep going? You could take out an e to the x, that's true. You could factor. I don't think multiplying by a conjugate is appropriate. No square roots, there's no complex fraction. If you take out e to the x, wouldn't it be e to the 2x minus 1? Here's the dilemma. Is anything canceling out with that x in the bottom? Nope. Okay. Log base if we had another side. We don't actually have another side. And even if we did do a log base, this subtraction is going to mess us up all kinds. Did anybody go to their calculator? Nobody did? I know, it's a good question. Whether or not you were allowed to, right? This would definitely, for your level, be a calculator problem. And what could you do in your calculator as you tried to figure out this limit? There are two things. You could either look at the graph or the table. For the table, what value do you put in to get closer and closer and closer? Negative 0.1, negative 0.01, negative 0.001. And then? Positive 0.1, positive 0.01, positive 0.001, right? Okay. No, you guys get your calculators out. Pause. You didn't know you were allowed to use them. Let's just pause. I was going to give you the answer, but I was going to do some calculus that you guys won't learn until the end of first semester. That's not going to help you right now. There are some limits right now that you cannot do by hand. And this is just to show you 0 over 0 does not always give you a keep going that you want. And, wait, what practice was this? Was this 1.3 practice or 1.2 practice? 1.2 practice. So is this the algebraic we're supposed to keep going at anyway? No. The graph and the table section. So it was totally okay for you to go to the calculator. So you're plugging in your function. Rachel's gone today, huh? Okay. Has anybody figured out what's going on? You guys can double check me, but I'm pretty sure the answer's 2. Now, how did I do it? You'll have to stay here all semester to figure that one out. Or you can ask a BC kid L'Hopital's, and you'll be like, what? Yeah. For help on limits, they might just be like, L'Hopital's, and you're like, I don't know it yet. And like, oh. And you can't know it yet, not until the end of first semester, because we have so much to learn before you can do that. It's not something where I'm holding you back, it's just you're not capable yet. Okay, so no L'Hopital's, even if the BC kids are like, oh, it's so much easier. They've learned a lot. Okay, so number 79, final answer is 2. Any questions on that one, now that you've been able to go into your calculator? Okay, number 80. Number 80. All right, this one's a little bit nasty. Did you guys agree with, I'm going to do one by one. Well, do you want to do the answer first? Now let's do it one by one. For Roman numeral 1, what do you guys think? True or false? How do you do it? Plug it in, because we know section. The calculator. What's going to happen if 3 minus 2? Ah, so that's true. That one's good. What's the square root of 1? Wait, are we okay? 3 minus 2 is 1. Square root of 1 is 1. I know. Roman numeral 2. True or false? True. Looking down below, we've already, 50% chance of getting it right. Go team. And then number 3. Ooh. Whoa. I mean, I guess we could go make a graph, but what did they have us do on these two? Look at the, if x is greater than 3, what side would that be on the number line coming towards 3, the above or the below? If x is greater than 3, what side is that? Above, right? So this would be greater than 3. This would be less than or equal to 3. So greater than 3, less than or equal to 3. If we want to come from above, we'd be going with this guy. If we wanted to come from below, we'd be going with that guy. So what happens when they don't agree? Does not exist. Final answer should have been D. Yeah. No, because we weren't actually saying f of x. But another way of asking yours is asking why wasn't there a 3 negative? Another way of asking for this one is that this could be the same as the limit as x approaches 3 from below of f of x. These are the exact same thing. So going from, not below, I apologize, that one should have been above, right? Yeah. The limit as x approaches 3 from above of f of x is looking at this guy. But it was just asking what's true about this. Oh yeah, the limit's 1. What's true about this? Which would have been the exact same thing, even though they didn't actually say it. Sorry, there's not room. Would have been the exact same thing as asking the limit as x approaches 3 from below. They just wrote it a different way. They said, hey, what's that guy? 0. Then you were supposed to, when they came down to here, realize, oh, wait, that's one side. Oh, wait, that's another side. And oh, wait, they don't agree. So they didn't actually tie it to f of x until the very, very end. They just said separately, what would you do here? Oh, what would you do here? Oh. Then they said, oh, hey, put it together, and then think of it. Does that make sense? Okay. Dun, 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 dun. How many of you guys got 1 right? Have you guys got, keep your hands up if you also got 2 right. And you also got 3 right. And you also got 4 right. Ooh, all right. Nice. All right, on your marks, get set, section 1.3, let's get back into it. Did we finish this one? I think we went fast at the end of class on this one, didn't we? Yeah. Okay. Is anybody still writing down? Last year, I'll leave it up for a little bit. Go ahead and get notes open. Last year, I don't remember if I said this yesterday. If I'm repeating myself, I'm sorry. I said it in period 6. I don't remember what I said differently in period 1 than 6 the next day. Sorry. Sometimes I do. But last year we would have had a whole page for this, and let's do some examples. A whole page for that, let's do some examples. A whole page for that, let's do some examples. But this year it's like, wait, you saw it last year, most of you, and you saw it in the summer packet. So now let's just practice. So what's the case? 0 over 0. What do? Keep going. What's going on in the graph? A hole, a discontinuity. But we keep going. Why? Why do we keep going? Why isn't a hole enough to stop and say, D-N-E? because the limit can still exist even if a hole is present. So we have to keep going and actually check and see, is this a hole where both sides agree, or is this a hole where both sides don't agree? And then we can figure it out from there. So this is some of the math that we're going to play around with. So now we're in section 1.3. Now we're playing with plugging in and simplifying and factoring and all that jazz. Okay, is anybody still writing? Oh, okay, a couple more seconds. Can I dual page it? How's our eyesight in here? Is our eyesight all right? Where's the love? All right, if we can keep going, here we go. Before we do examples, I want to show you the other thing that can happen when you plug in. You're like, huh! So there's plug in 0 over 0. Keep going. I actually want you to write keep going, because I want you to think keep going, because I want you to do keep going. Are we tracking? But the hard thing is, what if you plug in and you get number over 0? Not keep going. Number over 0. It's kind of like a screech to the halt. Screech to the halt, screech to a halt. You have to stop and you have to think. Because I've trained you, hopefully, and I'll keep training you so much on 0 over 0, keep going. Number over 0, it's like, ugh. It's the other kind of discontinuity. It won't be a hole, it'll be a vertical asymptote. And so before I do a way of remembering this one, which, just to be honest, it doesn't work as well as the keep going. I don't know why it doesn't. We need to think about vertical asymptotes. Let's just say that for all of these cases, we have a vertical asymptote at x equals a. Means a to a function. We get a, I don't know what that number is, could be positive, could be negative, could be anything from 1 to 1,000,000 or anything in between, or beyond, or going negative, the same thing. So whenever you plug in a to a function, you get number over 0. There is a vertical asymptote. So we have to think about, okay, wait. Vertical asymptote. Vertical asymptote. As long as it's a normal function, it's not like a weird piecewise-y thing. I want you guys to sketch what are the 3 different things that can generally happen as you go in towards a vertical asymptote. There are 3 different ways the 2 branches on the side can approach. Show me with your hands. What's one? I'm going with mix first. Sorry, I don't remember which one was which. I'm just doing the general idea. Okay, you have one up and you have one down. You have one up and you have one down. What could be a function that's like this? 1 over x, yeah, or 5 over x, or 7 over x. It'd be shifted, so 1 over x minus 2. Good. What's another case? Someone else. Got it. People in the back are like, going up. Maybe they're optimistic. Okay, good. People in the front, going down. I'm not calling you pessimistic. You're just smart. You're finishing it off. Okay. So, when will the limit exist? These 3 cases. When they're in agreement. So either the limit, right? Either the limit as x approaches a of f of x would equal dne, or positive infinity, or negative infinity. Those are our options. That's it. dne, positive infinity, or negative infinity. Those are our options. That's it. So here's the struggle. Well, how do we figure this out? Maybe it's a basic graph. We can just think about it real hard and be like 1 over x, negative 1 over x. Okay, it's going to look like, and then I can think about, oh, it's dne. Or maybe it's going to be negative 5 over x squared. Well, the 5, who cares? It's over x squared, so negative, it's going to be, oh, it's going to be negative infinity. But usually it's not that easy. Usually it's not that easy. So we do, instead of keep going, number over infinity, over 0, we're going to think infinity and beyond. Why am I making it infinity and beyond? Toy Story, I'm just trying to make it memorable. However, do you want to write infinity and beyond? The answer is No. So I want you to think infinity and beyond, but what we're going to write is plus or minus infinity with a big old question mark. Plus or minus infinity with a big old question mark. The big old question mark is you're not done if you think infinity and beyond. You're halfway there. Number over 0, infinity and beyond. But I want you guys to write plus or minus infinity with a question mark. Anybody know why? What do you see? All of them are approaching. Each branch is approaching either positive or negative infinity, and we have to figure it out. I'm going to give you clues for how to figure it out. It's actually kind of similar to stuff we did in pre-cal when we were determining, analyzing the behavior near the vertical asymptotes. It was leading up to you being able to do these limits. Okay? So let's go ahead and see what we've got. Ooh, hoo, hoo, hoo. We have all sorts of stuff. We have all sorts of stuff. We'll figure out how to do the infinity and beyond if we get to it, when we get to it. Maybe you guys kind of realize why this is not just a to dare. Because we're going to pause on these examples for just a little bit, figure out what's going on. And then if we have time, we'll go to the last topic. If not, it's okay. I have the homework planned to be done Thursday, which means we can take one more day of notes. But as you see this homework, it's a lot of plugging in, a lot of math, manipulation. For 0 over 0, keep going. Start. Homework. Come into 0 period. Ask questions where you got stuck. You can do anything that has polynomials. If you start seeing sines and cosines, maybe take, unless plugging in works. Unless plugging in works. Give you guys a second to get the first 2 written down. But then I wouldn't write the rest down because you're not exactly sure how much room to save, right? What do you guys want? Let me check in with you. How many of you guys are like, I think I can tackle some of these. What do you think? Oh dear. Okay. How many of you guys are like, I'm just too lazy to raise my hand because it's early? Okay. That's another few. Let's just do strategies then. Has anybody noticed yet what is the same, what is similar, compare and contrast with every example on the board right now? Every single one. What's the same? Besides the fact there's a limit with an x and an arrow. Don't tell me that. What's something that's similar besides they all have limits and x and arrows? They're all fractions. Good. They're all fractions. And then what else? Denominator always ends up being 0. Denominator always ends up being 0. Why didn't Ryan say top bottom 0 over 0? Some of them don't. Are 0 over 0. Number 1. Not 2? Don't be scared of fractions. Isn't it 1/2 minus 1/2? Where? Anyway, 1 over x plus 2 minus 1 over 2. Los siento. Any other 0 over zeros? Okay. So then what is this guy? Have you guys already figured it out? 3 over 0. What's this guy? Negative 7 over 0. What's this guy? 15 over 0. And what's this guy? Man, I gave you so many numbers over 0. Why? What did you do in the summer packet over and over and over and over again? Keep going. So you're used to that. So I didn't give you as many examples on that one. But these ones are keep going. What are all of these ones? Infinity and beyond. But what do we do? Infinity and beyond. Just like I want you to write keep going, KG. I want you to write plus or minus infinity and beyond. Ah, question mark. Plus or minus infinity, question mark. The question mark is like you're not done. Just plus or minus infinity. They forgot they weren't done. Don't ask me what answers I got. They were weird. Okay. I want you guys in your groups. You should be able to do number 1 and 2. Go ahead and collaborate right away because not everyone was confident. But at least 1 and 2 keep going. Those are review. But some people might need reminders. Ready, set, collaborate. See if you can get me 1 and 2 in the next 3 minutes. You guys ready?
It's like calculus in the force.
I'll take it. It is a force to be reckoned with for sure. Can I start playing? What was the trick that you needed to remember for number 1 when there was a radical? Multiply by the conjugate. Good. The conjugate of what? The top part or the bottom part? Who's the problem? The bottom part's the problem as far as being 0, but the top part's the one that I can't factor unless I somehow. Did you guys multiply the same top bottom? If not, you threw it off balance and it's not the same anymore. Has to be same top bottom. What do you have to remember? Don't kill seals. Remember your distribution. Does anybody remember the point of the conjugate? Outer, inner, cancel. Good. Because it's an A minus B and an A plus B. So your negative, positive AB, negative AB will cancel. The 3 root 3x and the negative 3 root 3x cancel. So what do we have left? Square root of the first, which is just square root squared is itself, minus square root of the last. Could you guys have written out the plus 3 root 3x and the minus 3 and cancel? Yeah, it's fine. Every time. Every time. Conjugates, outer, inner, cancel. On the bottom. Foil it. No. Why not foil it? The goal is to reduce him away. The goal is to get rid of the 0. To find the zeros that match and reduce. So therefore, summer review quiz. You guys did corrections. What did a lot of you guys forget? Nothing matches. Factor. What happens to 3x minus 9 when you factor out a 3? Yeah, buddy. Go team. What's left down here? Plug it in, plug it in. 3. Over. I do not rewrite the limit again because I'm now solving. Square root of 3 times 3? Square root of 9 is? And 3 plus 3 is? And 3 over 6 is? Anybody get 1/2 before me? Couple groups. Couple partial groups. Yeah.
Okay, I saw how you did that, but
Yeah.
you know why you don't have to rationalize that? Like, because there's a square root.
There is a square root, but first of all, it's not an answer, it's an in-between step. So since it's not an answer in-between step, we don't have to rationalize. We just go for it. And we see that 3 times 3 is going to be a nice perfect one. But also in calculus, you never have to rationalize a denominator in an answer. It's no longer a thing. Ain't nobody got time for that. Doesn't mean it won't be helpful to see, because maybe an answer in a multiple choice will have rationalized. Multiple choice is hard. You have to make it match, and the answers are sometimes different forms than you're used to. But it is no longer a thing where I will ever make you fully simplify an answer. Because to be honest, we're going to get really... Stick it to the man. Why? If you're on a long answer part of an AP exam, you never simplify. Because all of us make dumb mistakes, and it would be a shame. And it's taught like nationwide. Anyone who wants their kids to do well in an AP exam has gone to a conference before. Don't simplify long answers. Why? The AP graders, just like me on tests, hate being like, oh, they did all the calculus right and distributed a negative wrong, or 0 times root 3 is not root 3, or whatever. So we're going to learn to not simplify to save ourselves from silly mistakes. So that can be a reason, Nick, in the back of your mind. What's going on here? Trick. Not trig, sorry, trick. What's the trick that you want to remember? Not multiply by the conjugate, but? Yeah, multiply by the denominators. What do I mean by that? Who are my little stuck denominators?
X plus 2 and
2 and x plus 2. But what I do on top, I must do on the bottom. Okay, summer review corrections. Did we do it? Those of us that missed the complex fraction-y one, did we figure out how to do it? Okay, so I'm going to go ahead and, if it was barely, I'm going to show all the work. What happens to these two when they come in? Well, I have 2 and x plus 2 all over x plus 2. What happens when they come in again? Well, I have 2 and x plus 2. Maybe some of you tried to do too much mental math. Just do it. That times that. All right, cool. All over. Well, I'm going to put the 2 in front. Is that okay? You might need to write this out, but what happens if you write it out? And maybe as you get better and better and better and shortcut, what's going to happen every time to one of the denominators? What's going to happen to the other denominator? But what's left? The limit as x approaches 0 of. Don't I have 2 minus? Why am I going to do minus x? Distribute. I'm not killing skills. Some of you did that on your quizzes. The 2's cancel. The x's reduce. But what's left? -1. Why am I going to write an equals and not write a limit and write -1 all over 2 times 0 plus 2 is 4? Dun, 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 dun. Because I solved it. What did we practice today? Plug it in, and get 0 over 0. Keep going. Now wait. Oh, you all just assumed because I was trying to summarize the day that I was done. I still have time for one more. But let's do it all together. Let's do it all together. What's different with 3 over 0? Infinity and beyond. It's a vertical asymptote. And vertical asymptotes, either they agree from either side or they disagree, or they agree a different way. What am I supposed to do? I'm supposed to check from below and check from above. But the nice thing is when you're checking vertical asymptotes, you don't actually need to worry about the number itself. You don't actually need to worry about the value itself. We know it's going to be some sort of infinity, just which one. So maybe some of you guys remember from last year, we had a trick to solving. And the trick to solving was plugging in, this is my little like understood off to the side, was plugging in a number that would be right below 1. And we just check the sign. What's the number right below 1? Pause. How about 0.9? Not 0.01. All over, and then 0.9. What's the sign of the top? Positive, I don't know, it's positive. What's the sign of the bottom? And what's a positive over a negative? Dun, 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 dun. Do the same thing with 1.1 and then compare and say, same answer, different DNE. Woo! All right, cool kids, tonight work on 0 over 0, keep going, and the easy plug it in ones. If you get to number over 0, maybe try them. I'll see you tomorrow. Or tonight. Not tonight, this afternoon. Or tomorrow morning before school. Happy Tuesday.